All right, this is the last section of this chapter, so what's coming up pretty soon then? Tests. I don't know exactly when it is. Depends on how long it takes to do this. It could possibly be at the end of next week. All right, be my guess. All right, I don't think it's going to take us that long to do one lesson. I would say probably towards the end of next week, maybe Thursday. You'll know on Monday. I'll do my lesson plans this weekend. I'll figure out what I want to do. I still got to. I'll probably at least take one more day on this stuff right here. So, all right, let's do this. Let's grab a graph and make this kind of big so I can see it. There we go. Pretty big. All right. All right. What was this thing called? Coordinate geometry. Coordinate. What are we talking about? Well, I gave you a big old hint because I put this graph right there. But the coordinate, right, is doing points and all that, making a line out of it and all that kind of stuff. Okay. So that's what we're gonna do. All right. Coordinate geometry of what? Triangle. So we're not just going to put any old random lines. What do you think those lines are going to form? They're going to form a triangle, exactly. So what we're going to do is this. I think this first example, they actually give you the graph and ask you a question about it. All right, and so the first point they give you is point A. It's negative 7, 1. We even have 7 things here. 1, 2, 3, 4, 5, 6, 7. Good. Negative 7, 1 would be right here. That's point A.
And then butter to your office, please.
Okay, and I'll even put the number in here, negative 7, 1. All right, then point B is 1, negative 5. So 1, 1, 2, 3, 4, 5 is right there. That's point B. And I'll put the coordinate 1, negative 5, just so we remember. And then C is at 7, 3. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. That's point C. And I'll put the coordinate 7, 3. What do you think we're going to do with these 3 points? Join them all up and make a what out of it? Triangle. Okay. And they're going to ask you a couple of things about it. All right, there we go. That's nice and pretty, isn't it? All right, so they're kind of leading you up to something they're going to do a little bit later. All right, so we'll talk about that when we get to it. Let's just answer the questions that they asked of us. Let's shove this over a little bit like this. Give me some room to write over here. All right, let's go back to the right and let's see what they say. They say find the slope and the length of each side of the triangle. So this shouldn't be hard at all. This is all stuff that you already know how to do. It's been a little while since we've done slope and the length of a line segment, but find the slope and length of all 3 sides of the triangle. Of sides of the triangle. And what should I name this triangle? Yeah, ABC. We'll name it ABC. Everybody with me? So let's do it pretty quick. All right, you should know how to do this already. Let's do the slope first. I just finished teaching this today in my CP geometry class. Remember what it is? How do you find the slope? It is rise over run, but when you have points like this, what do we? Y2 minus Y1 over X2 minus X1. Okay, so I'll tell you what, let's move this over a little bit. So it may be off the screen. Because YouTube kind of cuts off a little bit of the edges a little bit. So I'm going to put slope of AB. Is that all right? I've got M for slope. AB means I'm going from A to B, this one right here. So let's find the slope of AB. So I'm using these 2 points. I'm using negative 7, 1 and 1, negative 5. Everybody see that? If you wanted to, just to make it a little bit easier, you could say, actually, this. You could say A is what? Negative 7, 1. B is 1, negative 5. and C is 7, 3. Then we can just look here instead of looking at the graph every single time. Is that right? Okay. So the slope of AB right there. So what are we going to put in here? Negative 5 minus 1 over 1 minus negative 7. Did I do that right? So that's negative 6 over what? 8. Do we leave it like that though? No, it would be what? Negative 3 over 4. Okay? Everybody with me? Yeah. All right, and let's do the others a little quicker. So let's do what? BC. BC, these two right here. So it's 3 minus negative 5. And then it's 7 minus 1. So that would be what? 8 over 6. And what's that? 4 over 3. I think we talked about this. Have we talked about the slopes of parallel lines and slopes of perpendicular lines? Yeah, I thought we did. Do you notice something about AB and BC? Yeah, AB and BC. Look at that. You know for a fact now. How do you know that they're perpendicular? I didn't put the box there. How do I know they're perpendicular? Well, they're what's the phrase that I use? Negative reciprocals. Oh my, I didn't have my microphone on. I was probably it's terrible sound, and now it probably sounds better. All right, so these are perpendicular to each other because they're negative reciprocals to each other. All right, so that's kind of interesting to see, right? I might have guessed it, right? But just looking at it, do you know 100% that that was a right triangle? Not 100%, but if I find the slope of this one and the slope of this one, and if they are negative reciprocals of each other, yes, I can say that they are perpendicular, which means they're right. It's a right triangle. Okay, so that's kind of nice. What's the other one we're missing now? Slope of what? Yeah, AC or CA. All right. And let's do A and C. It's this first one, this third one right here. So it's what? 3 minus 1. And it's 7 minus negative 7. What's that? 2 over 14. Reduce it. 1 over 7. So that's all they ask you. Again, they're leading you up to something else. I mean, just finding the slopes of those lines is not that big of a deal. But right here, this is kind of what they're hinting at. This and this. Okay, if those two slopes are negative reciprocals of each other, you know that they're going to be perpendicular. Everybody with me so far? Yeah, easy, no big deal. Let's do this. Let's find the lengths of the sides. So what formula am I going to use to find the lengths of the sides? What is it? Add it? Is that what you said? Distance formula, right. I'm going to use the distance formula. So when it says find the length of a line segment, we are going to use the distance formula. Do you remember what that is? I'm not going to write it down because I'm going to write it down 3 times when I put the numbers in. So let's go in the same order. Did we do AB first on the other one? All right, so let's do the distance of AB. All right, so big old square root. Remember what we put inside here? You had quiz, you had a test on this stuff, right? It's been a little while. It's been a whole chapter ago. What do we do inside of here? Yeah, we subtract the x's, and it really doesn't matter what order we subtract them in. So we're doing an AB, so let's subtract the x's. So I've got negative 7 minus 1. Then we subtract the y's, 1 minus negative 5. Let's simplify that. We could probably do some of this in our head. This is going to be negative 8. Negative 8 squared. Well, when I square that negative, it's just positive, right? So this basically is just 8 squared. What is 8 squared? 64. You okay doing that much in your head? Yeah, I think so. What's this going to be? 1 plus 5, which is 6. 6 squared is 36. Okay? This is 100, right? What's the square root of 100? 10. So look at that. I can find it pretty quick and easy. You can fill in the gaps if you wanted to, but we got 3 of them to do, so I just want to get it done fairly quickly. Everybody understand that? All right, so let's do the other one. What was the other one? BC? All right, put the big old square root. B and C, so these right here. Well, I always like to do this first. What do I call this of my equation before I start sticking the numbers? Yeah, I call this the shell. All right, I like to put all this in, and now I'm ready to stick the numbers in. So I subtract the x's. I'm doing BC, so I'm doing these two right here. Subtract the x's. What do I get? 1 minus 7. Or you could go 7 minus 1. If you didn't want it to come out negative, you could have gone 7 minus 1, because you're going to square it anyway. What happens when you square it? It's going to come out positive, correct? All right, let's do the y's on BC. Negative 5 minus 3, or you could go 3 minus negative 5. It doesn't make any difference. I'll just go negative 5 minus 3. Let's see if we can do this in our head. 1 minus 7 is negative 6. Squared is 36. Don't forget the square root. Oh, that's an ugly square root. Let's make it a little better. That's better. Plus, this is negative 8. Does this look familiar? Yep, 8 squared is 64. That's 100. Square root of 100 is 10. So what does that mean? That means that AB is what? Equal to BC. So just by finding the slopes, I knew that it's a right triangle, that these two are perpendicular. And by finding the distance, I could tell you that this side and this side are equal to each other. Now, if this side and this side are equal to each other, what's true about these angles? That angle right there. So angle A would equal angle C, wouldn't it? So there's a lot of stuff. Just by finding the slope and the distance, there's several things that you could know about that triangle that you may not have known before. All right, let me slide this up just a little bit. All right, now what are we going to do? AC, distance of AC. Now, if you wanted to, well, the distance formula basically is the Pythagorean theorem, isn't it? Remember that when we went over it? Because we said the length of that is 10, right? The length of that is 10. So you could just go what? 10 squared plus 10 squared equals c squared, right? Remember that? But that's what the distance formula does anyway. Its distance formula is taken from the Pythagorean theorem. But since we're on a roll, let's just keep using this. All right, so AC, we're doing this one and this one. So subtract the x's from each other. So it's negative 7 minus 7, right? And it's 1 minus 3. This is negative 14. I have no idea what that is. Well, I do. I wrote it down on my paper. It's 196 when you square it. You know what this is. 1 minus 3 is negative 2. Squared is 4, correct? And then it's under a square root. So what's this one? This is the square root of what? 200. At this point, I mean, since you're honors, I really should make you simplify this, okay? If it was a CP class, I'd probably be okay with them just keeping it square root of 200. So let's simplify it. This is good. This will be good for you when you take Algebra 2 because you're going to have to do this stuff in Algebra 2 anyway, okay? So let's break this down. What times what is 200? And hopefully one of those numbers you can take the square root of really easily. 2 times 100, that's what I would do. In fact, I'd go 100 times 2. Doesn't matter, you can go 2 times 100. Remember what we said in algebra you can do? If these two things are being multiplied under one big square root, do you remember what we said we could do? Put them both under what? Their own individual square root. There's a rule in algebra that says we're allowed to do that, okay? It makes sense, doesn't it? Right? The square root of 100 times 2 is the same thing as the square root of 100 times the square root of 2. Kind of makes sense, right? And what is the square root of 100? It's 10. And how do I show that times the square root of 2? I just put it next to it. That is the way you should write your answer. Okay? So this would be what? 10 square root of 2. There's something else. At the end of the year, we're going to do some trig, all right? And you're going to be able to just look at this, know a few rules that we're going to talk about, and just write this down without really doing any math in your head. Doesn't that sound exciting? No. Sure it does. All right? Knowing that this and this are the same. By the way, if this angle and this angle are exactly equal to each other, I could tell you, I should have said this earlier, but you could figure out exactly how many degrees that angle is and that angle is. Do you know? What is it? It's 45. That's right. Because these two have to add up to what? To 90, right? Because I got a right triangle, right? These two would be 90. Added to this, that would be 180, right? If these are exactly the same and they add up to 90, they both have to be what? 45 degrees. Now, they don't ask that in this question, but I think it's good for us to look ahead a little bit and see. So that's kind of interesting, isn't it? Question? Okay. So all they did, they just asked to find the three distances, and there they are. I just want you to look ahead a little bit and just see some stuff. All right, enough of that. Go ahead. How did I know this is 90? Because I erased it, but remember I did the slopes? The slope of one was, what was it, negative 3/4, right? This one was negative 3/4, and this was what? Positive 4/3. They're negative reciprocals of each other, so that means that this line and this line right here are perpendicular. If they're perpendicular, it makes a right angle. So if that's a right angle, that's a right triangle. If it's a right triangle, you know that these two are equal. How do you know those two angles are equal? Because we just found that these two sides were equal, right? If these two sides are equal, and this is 90 degrees, these angles would equal, and they'd also add up to 90, right? So what are, if they add up to 90, and they're both the same, just divided by 2, you get 45, okay? And then later on in this year, towards the end of the year, we're going to learn that this side right here, this hypotenuse, is 10 square root of 2 without doing any math at all. Just looking at it, you'll be able to tell. That's kind of fun, isn't it? Yeah. All right. I'm sure it sounds like a blast. All right. Let's do another one. Now we're going to do something that you probably haven't. Well, I mean, you've seen this picture, but just going to draw some random triangle, nothing super special. Kind of looks like it might be a right angle, but it doesn't really have to be. Looks a little bit more than a right, I don't know. So what I'm going to do is this. I'm going to find the midpoint of two sides of the triangle. Let's take this side over here and this side right here. Everybody watching? So I'm going to come over here, and can you see it on the screen? Yeah. See that little blue dot right there? So on this program, when I click on it, it shows me where the midpoint is. That's kind of nice. So I'm going to draw a little point right there. So what did I just draw on that side? The midpoint. What do you think I'm going to find over here? Find the midpoint of this side. Okay? And there's something special about those two midpoints, or what I'm going to do with those two midpoints. All right? So watch this. Everybody see what I just did? I just found the midpoint of any two sides of the triangle. I just happened to pick this one and this one. Okay? I could do this with any two of the sides. I decided on those. Now, what if I connected the two midpoints together from there to there? See what I did? Now, it's the midpoint, so that means this and this equal each other, right? That's the midpoint of this side, so that means this one and this one are equal to each other. Just by looking at it and guessing, it is half the bottom. That's good. I thought you would say something else, because usually people don't get that part first, but that's exactly right. We'll show you that in a second. But what else might be true about this one and the bottom one? It's parallel. Very good. Okay, they definitely look parallel, don't they? All right, and that's exactly what this. Well, actually, it's a theorem. Oh, you know what? I might skip some of this just because of time, so we get through most of this. We actually went through. Oh man, yeah, we don't have much time today, so I hate to skip that. That's okay. I hate to say this, I really do, but just believe me that that's true. All right, I hate doing that. But they show you in the book. If you don't believe me, right? You have doubts. I don't blame you for doubting me. But if you did doubt me, they go through example 2. So example 2 in the book actually goes through, and it shows you. It's not really a proof, but it's kind of a demonstration that this side right here is parallel to this side. Maybe we'll do it on Monday. All right, remind me. Maybe we'll do it on Monday. And they'll also show you that this is half of this. Here's what I can do with this. With this program that I have, it's kind of nice. I'm not just writing on a board somewhere. Let's make this a different color. Check this out. What if I take this and put it right there? See that? And then we'll make it a different color. if it is half of the third side, if I grab the stupid thing, there it is. Watch. If it is, look at that. Would you agree? Look, I copied and pasted, right? I took that red one, I copied and pasted. So that red one and this green one are the same length. That red one and this yellow one are the same length. Natalie, question? It's exactly half of this. I don't know what you mean by right there. What do you mean by right there? What's that? Sure. I mean, I just don't know what you're asking. So, but this and this are the exact same length. Do you believe me? No. Look, right there. Do you see it? See that red one? Is that green one? Same exact length. Now, do you believe me? Yes is the answer. Okay. And I copied and pasted, and that yellow one is exactly the same. So check this out. So the bottom is twice as big as this middle one, right? Or the middle one is what? Half of the bottom one. And that's what we're going to use, okay? Let's get rid of this green one and yellow one. I mean, that was good enough, right? Is that enough for you to believe me? Yeah. And also, if I take that red one, and let's just take let's do it again. Let's take the red one. I copied it. I'm not changing the angle of it. I'm just moving it down. Look, it's perfectly aligned with the bottom, isn't it? So what do you think they're parallel to each other, aren't they? Do you agree? Yeah. Not the best way to prove it, but at least you see it, right, visually, that, yeah, that must be true, all right? So that must mean that this red one is parallel to the third side. By the way, I almost forgot. Wow. This has a name. So this is a line segment that connects the midpoints of any two sides of a triangle. It doesn't have to be any kind of special triangle. It could be any kind of triangle. If I found the midpoint, okay, of any two sides of any triangle and I connect them, then we have a thing called the mid segment. It's not a midpoint, it's a mid segment. Makes sense, doesn't it? Because it's the segment that connects what? The two middle ones, right? The two midpoints. It's called a mid segment. Go ahead.
If you found the midpoint for one of the sides on the bottom, equal the other line?
Yes, if I found the midpoint of this and I found the length of it, it would equal this. Exactly right. Everybody with me? So, the mid segment. There's two things that's true about the mid segment. Okay? One thing is that they're parallel, right? So, what can I say? DE, line segment DE is what? Parallel to line segment BC. All right? And what did we say? The length, correct? The length of DE. Now, if I talk about the length of DE, do I need to put a line segment over top of it? No. When it's the length of, you just write DE, and you don't put anything over top of it. So I'm going to write DE is equal to what? Is DE equal to BC? No. DE is equal to how much of BC? Half of it, yeah. So DE is what? Half of BC. So those are the two things that are true about any midsegment of a triangle. I could have connected this one and the midpoint of this side. Everybody see that? And then I could have had a line that's going like this. Well, what's true about that line? DF, we'll call it. It'd be half of AC, and it'd also be parallel to AC. Very good. Everybody with me on that? And again, it doesn't matter what kind of triangle you have. It doesn't matter what side you pick. All right? The midsegment will always have those two things true. It's always parallel to the third side, and it's half of the length of the third side. Or you could say this. You could say, I'm going to put or. You could say that the length of BC is what? Compared to DE. BC, the length of BC would be what? No, not half. BC compared to DE. DE is half of BC, but BC is, say it, double. It's twice. Twice DE. Everybody see that? See, I changed it around a little bit. All I did was multiply this side by half, didn't I? All right? So either way you want to look at it. So, for instance, What if I said that that's the mid-segment right there, and I said that this is 5? What is BC equal to? Come on, quick. 10, thank you, okay? Shouldn't have to think about it now, right? Because remember, this is half of this, or this is double this, right? What if this was like, I don't know if this will come out nice or not. What if this was x plus 2, and this was, I don't know, 3x. Oh, it's terrible. Let's try that again. 3x. I don't know if this comes out nice or not, but what if that was 3x minus 4? What would you do? Okay. Yeah. So 3x minus 4 equals, let's just write it like this. So what would 3x minus 4 equal? It would equal what? Twice x plus 2. Not 2x, it's x plus 2. Now, I don't know if this works out real nice, but you could solve for x and you could find the length, couldn't you? Does this work? It might work. Let's see if it does. I just made those up off the top of my head, so I'm not really sure. So equals what? 2x plus 4. Nah, I don't think it's going to. Oh, yeah, it'll work. It'll work. So minus 2x from both sides gives me what? X. Add a 4 to both sides gives me what? 8. So what's the length? We're not doing this now. Okay, it's different numbers. So what's the length of DE then? If x is 8, that would be what? It'd be 10, wouldn't it? Okay, what would the length of BC be equal to? Without even plugging anything back in, what would it be? It'd be 20. Let's see if it actually is. 3 times 8, 24. 24 minus 4, it's 20. It works, doesn't it? Okay? That's the kind of stuff that they would ask you with this. So that's mid-segment. That's really important. Okay? You see that quite a bit. Man, I wrote a bunch of stuff on here, no wonder. I tell you what, I'm just going to stop right there. We can, I split this up into 2 days anyway, so I will cover the rest of it tomorrow, or not tomorrow, but on Monday. So, what did I give you? 1 to 14? All right, so we call this section, what, 4, no, I'm sorry, 1 to 16, 4-7A. Yeah, so let's call it 4-7A. And it's numbers 1 through 16. Page 196, 197. Should be on the lesson plan thing that I gave you on Monday, but there it is, just in case. That's your homework. Yeah, I think we are going to have a quiz. I got to look and see, but I do all that on the weekend. I'll let you know on Monday what's going to happen next week. So, why would we not have class on Monday? What is it? Oh, yeah. You're right. We may not have class on Monday because that's when they usually have it at like around 1 o'clock or so. So, yeah, I'm going to have to double check on that before I do my lesson plans. But we'll play it by ear, see what happens. All right? Okay.